All right, so yesterday, when we proved that triangles were congruent, okay, all three sides and all three angles had to be congruent, right? The good news is that we're going to spend the next probably week and a half talking about all the different shortcuts that you can prove triangles congruent by. Okay, so that's kind of nice. The first one that we start with is side, side, side. Okay, if all three sides are congruent, then your triangles are going to be congruent. So you wouldn't even have to worry about your angles. If you can get all three sides to be congruent in your triangle, okay, then you know for sure they're going to be congruent triangles. Okay, good news, right? Get to take some shortcuts. Okay, so if we look at this, okay, what do we always start with? The given. Okay, so we're going to write down, we've got BC is congruent to BF, and CD is congruent to FD, because that is given. Okay, they did some nice markings on their picture for us. That was very nice of them. Okay, what else can I say, according to that picture, what else is congruent? That shared side, right? Okay, so BD is congruent to BD. Yes, why? Reflexive, yep, we always use reflexive in that. Oops. Okay, the nice thing about this, guys, is that anytime you see a picture like this where there's a shared side, you can automatically say that side is congruent to itself. Okay, now, are all three sides congruent? Yes. Okay, so are my triangles congruent? Do I have enough information to say my triangles are congruent? Yeah. So, triangle BCD is congruent to triangle BFD. And why? Why are they congruent? I'll give you a clue right here. SSS, side, side, side. Okay, and that's how you can abbreviate it. You can just go side, side, side. Yeah, a lot easier than trying to prove all of them are congruent, right? Okay, so now we need to talk about, because we're going to talk about side, angle, side, we need to talk about what it means to be an included side or an included angle. Okay, so when we talk about it being included, we talk about it being in between the two things. Okay, so in this case, we're saying angle A is the included angle of AB and AC, because it's the angle that's in between this side and this side. Does that make sense? Okay, we say that the side BC is included between angle B and angle C, because it's between those two angles. Okay? Does that make sense? Okay, so right now we're just talking about included sides, or included angles. Okay, so in this case the included side is BC, because it's between angle B and angle C. Okay? And the reason why we had, well, okay, let's talk about this. Okay, so we've got side MT and TR. So between these two sides, what's my included angle? Angle T. Okay, because angle T is in between those two sides. Or it's formed by those two sides. You could think of it that way too. Okay, then we have TQ and QR. Angle Q, yep. And RT and RQ? Angle R, yeah. Okay, now, The reason why we had to talk about that, okay, is because we can also use the shortcut side, angle, side. Okay? If you have two sides and the included angle, so it's got to go in the order of have a congruent side, then an angle, then a side. Okay? So it has to go, the order makes a difference. It's got to go be a side and then the angle in between the two sides that are congruent. Does that make sense? It can't be side here, and then this angle right here. It's got to be the angle in between the two congruent sides. Does that make sense? Okay? So if we talk about this, okay, what do we always start with? The given. Okay, now, are there any givens written for us? No, but did they give us some information in the picture? Yeah, so let's write down the information they gave us in the picture. They told us that okay, well, let's start with BE since I wrote that. So BE is congruent to EC. And what else? AE is congruent to ED. And we can say that that is given because they already had that in their picture. Okay. Now looking at that picture, is there anything else that I can say is congruent? Yeah, why is angle 1 and angle 2 congruent? No. Because they're vertical angles, yep. So we can say that those are congruent because they're vertical angles. Now do I have enough information to say that my triangles are congruent? Yeah, so now I can put down my prove statement, what they wanted us to prove. Triangle AEB is congruent to triangle DEC based off of what? Side, angle, side. So in this case, we had side, angle, side, and we can just put SAS. Okay? So if we look at this, can we say that these two triangles are congruent in number 3? We can. Why can we say that? Because of side, angle, side. Yep. Yep. Okay, how about number 4? Can we say number 4 is congruent? Okay, let's think about this. Do I have 3 sides? I do? I have 3 sides congruent? No, I only have 2 sides congruent in number 4, right? So that doesn't work. Do I have, if I only have 2 sides, can I prove that the included angle is congruent? Well, we don't know JK and GF. So right now, the only thing that we know, based off of what's on our picture, is that FH is congruent to HJ, and that HG is congruent to HK. Okay, I don't know that third side. Okay, so if I don't have that third side, do I have the included angle? I don't in this case, right? Because those aren't vertical angles. So do I have enough information? No. So in this case, we've got to go not enough info. Okay. Over there, they give us how many sides? Well, they have 2 sides marked, right? Okay, so then we have to ask ourselves, can we do the third side? Yeah, because it's a shared side, so we know that we have that shared side. So now are they congruent? Yes, based off of side, side, side. Very good. Okay. I also have this that I think might help us with our worksheets. Okay? When you are doing your proofs, okay, you always start with your givens and you mark your diagram. Okay? Then, I know we haven't really talked about it today, but we'll get into it a little bit more tomorrow or next week. Okay, if you've got angle bisectors or segment bisectors, you've got stuff that's congruent. Okay, if you've got perpendicular lines, you're going to have stuff that's congruent. Okay, if you have parallel lines, and that was on yesterday's assignment, parallel lines are you've got to look for either alternate interior angles or corresponding angles. You always look for vertical angles, you always look for a shared side or a shared angle. That's going to be reflexive. Okay, so if you look at example 1, okay, so in example 1 you have a what? But you have a shared side. So in this case, if you have a picture that looks like this, you have that shared side, and you know that you're going to use the reflexive property. Okay, so you can kind of compare some of your proofs with these, and when you're looking for that missing information, okay, this is what some of them are going to look like. In number 2, what do you have? You have vertical angles, so angle T is 2 different angles. Angle PTF would be congruent to GTS. Okay, so remember, you can't just call it by one letter if more than one angle can be formed by that letter. Okay, and this is why would those be congruent? Vertical angles. Yeah, this isn't our worksheet, guys. This is just going to be able to help you do some of your proofs. How are you going to find some of your missing information? Okay, so if we look at number 3, it gives us what? What's it saying given? Parallel. It gives us parallel lines. Okay, and almost always when you're doing a proof, okay, and you have parallel lines, you've got to look for alternate interior angles. So what are my alternate interior angles? Angle X has 2 different angles. WXZ would be congruent to YZX, because those are alternate interior angles. Is there another pair of alternate interior angles? There's not? Yeah, there sure is. Angle WZX is going to be congruent to angle YXZ, because in this case we started with W, so over here we got to start with Y. And those are also alternate interior angles. Okay, everything else, it looks like we'll deal with the backside next week. But this gold sheet will help you pick out some of your missing information.